Once again, thank you very much for joining us for the third Sales Summer Seminar. Today we have Bibek Upadhayay joining us from our very own Sale Lab, who's been with us since, I believe, fall 2019. He's worked on a couple of projects and he's going to present his recent work on fake news detection using machine learning. Bibek, the floor is yours.
Thank you, Dr. Vaid. Hello, everyone. I'm Bibek Upadhayay. I'm a CS grad student at University of New Haven. I've been working with Dr. Vaid in Cell Lab since last fall. It has been a wonderful journey. And throughout the year, I've been working with Dr. Vaid in various projects. And this is one of the research that we both wanted to start. So we've been working on this since last 6 months. So let's get started. Okay, so the topic of our presentation is classification of fake news using deep neural network. So first, let's start what is fake news. And we will start with a simple definition, although the definition of fake news is very broad. So we're going to narrow it down into two sole definition. So any article that is intentionally and verifiably false, we're going to call that fake news. And also, if information in the news article is factually incorrect and it is designed in such a way that when the user is reading it, it believes that it is true. And we're also going to call that a fake news. Because fake news, nobody writes it just without any motive. There is always motive behind fake news. It could be a malicious intent just to hurt or disrepute. The motive could be for any profit, for example, for financial gain, by influencing the stock market, by influencing the views. It could be written in order to manipulate public opinion, right? Or it could be written in order to create disorder or confusion. So there are different motives behind fake news. So that's why you need to know that there is intention behind a fake news, and the information in the news itself is incorrect. So why are we talking about fake news? Why now? The rise of fake news has never been this great before. Like, it has been growing day by day. One of the main reasons is because with the increase in the internet, and internet has become much cheaper than ever. So the growing internet gives us growing social media, which gives us more uncensored platform, and there are more audiences increasing every day. So, and the problem with these audiences is that the large number of people are consuming news from social media, not from the mainstream news outlet. And news could be published by any source. It could be verified source, it could be unverified source. Even users are considering news if their friends are posting them in their Facebook or in the Twitter. So there is no a particular definition of news inside the social media which gives rise to the fake news. The factors that are contributing to this one are naive realism, confirmation bias, and normative influence theory. So these things form an echo chamber for that particular user, and they live inside this filter bubbles, which is given by this personalized recommendation by machine learning algorithm. For example, if I'm a big fan of hip hop, and if I've started listening hip hop music in YouTube, then suddenly I'll start getting particular kind of same hip hop kind of music recommendation in my YouTube. I'll start having friends and users in Facebook who likes hip hop, and same goes on for other choices. So these echo chamber and filter bubbles create a certain communities within of social media that gives rise to these fake news articles, right? For example, we can talk about the latest fake news that has been going on, and it's also now one of the biggest fake news of this 2020, that a coronavirus is caused by 5G. As we can see that there are like 487 communities within Facebook, 84 accounts and 52 Twitter accounts. And this was back in March. Not only that, the top 10 most popular 5G coronavirus videos was watched by 5.8 million times, and there are 58,000 followers that got increased to follow this news, right? So if you look into this different perspective, we can see that's more of an infodemic rather than the pandemic. And not only that, the the rise of Facebook, the rise of fake news is that the same conspiracy is now over 30 different countries via Facebook. Now we can see that the potentiality of the rise of fake news, like how a simple one statement could propagate in such a big way. And if we are thinking, okay, some might be joking about this one, but what's the impact, right? So everything has consequences, so as the fake news. Let's start with the social political impact. We can see that we all know what happened in 2016 presidential election in the US. The fake news played a very vital role that not only threatened the democracy, but also journalism and the freedom of expression of many journalists and users. The second greatest example of fake news making any change, any negative change, is Brexit referendum. Not only social political impact, we also can see the economical impact. The fake news claiming Barack Obama was injured in explosion just made $130 billion value loss in stock. And the more important impact is the violence and chaos that we need to be more careful. Just that one story of 5G causing coronavirus created a chaos in the UK, which allowed like nearly 80 mobile towers got burned down into that. More than 40 employees were physically or verbally attacked by those communities. Not only that, there has been a story in 2016 to 2017 in which fake news and fake users pages on Facebook, they incited genocide in Myanmar. So these are the impacts of fake news, which is why we need to find out fake news and try to lower the risks of fake news, as well as try to remove fake news. So the first thing is we need to find it, right? So how can we find that? There are two ways that we can look into. The one is the traditional way, in which journalists and experts look into the news that seems to be false, and they do the fact checking by hand. They try to confirm the news or the variable sources. That's how they verify the authenticity of the news. There are two main organizations working like this: PolitiFact and Snopes. PolitiFact, especially, they are one of the supplier of the liar data set. So we can, if you go and look into their website, you can see how they do the fact checking. It's really amazing. But if we try to mitigate the fake news in social media by traditional ways, that's not possible, right? There are millions of them. So that's why we need a modern approach. And one of the trending approaches is using application plugins like BS Detector and Cross-Check. But they are not enough. We need much more approach rather than just using plugins. So that's why we're going to talk about fake news detection and classification using machine learning approach. We can classify the machine learning approach for the detection into two parts: non-neural network methods and neural network methods. In non-neural network methods, we can talk about anagram, part of speech tagging, probabilistic curtis, phrase grammar. But the thing is, there's always a limitation to this non-neural network method. They are good if we're trying to separate it. For example, if we're trying only to look into the syntactic information or syntactic information using part of speech tag, they might be good for those kind of classifier. But when it comes to fake news that are lengthy and where we need to find the dependency of one part of one entity inside the text to other entity, then these non-neural network cannot fully extract and exploit the rich semantic and syntactic information in that content. So that's why we need neural network method. In neural network method, let's talk from the basic. So we have there have been research that in which people use RNN in order to find the in order to classify the news article. So RNN are feed-forward neural network method that has a little internal memory that helps to create a dependency from one sample to the another sample. But the problem with the RNN is that even the memory is small, it gives rise to either the vanishing gradient or exploding gradient. And that's the one main reason that it cannot process the long sequence and cannot make relationship between them. In order to solve this problem, we have a LSTM, that is a long short-term memory. And this is also kind of RNN that is mainly used for sequence processing. It does solve the problem of the RNN. It's solved by, it has 3 gates: input gate, forget gate, output gate. Based on these 3 gates, it is able to make the relation or able to memorize the dependency of different samples. So which is why most of the time we use LSTM rather than RNN in classification problem. Another one is a convolution neural network. It is made of a convolution layer, pooling layer, and activation function. CNNs are also great for classification because they are really good at extracting the localized feature from raw input. And the good thing about CNN is that they are really good at preserving the relationship between those particular features. But let's talk about one more thing that we're going to use, transformer. Not this one, we're going to talk about much cooler transformer, that is this one. So what are transformers? So transformers are basically encoder block and decoder block. There's encoding and decoding going behind the transformer. Encoder are simply built up of a stack of encoders, and decoder block is built up of a stack of decoders. And if you look into this one, we can see that what's inside both of these blocks, right? So the most important thing that we need to focus on over here is multi-head attention. And as you can see that after multi-head attention, this is simply feed-forward network. And if you look into the if you look into the decoding block, we can also see that there is multi-head attention and feed-forward network. So these are simply made up of attention mechanism and feed-forward neural network method. But why attention here, right? So there was one paper published, Attention is All You Need, in 2017. So this paper make it possible for transformer to perform so well because attention make it possible to create a relationship between different entities within even a longer sequence. So this is why attention is so important in transformer. And not only that, by using the transformer, it also lends itself to parallelization. So it is much faster than CNN. Let's talk about another transformer that we're going to use. We're going to talk about a BERT. So BERT is basically bidirectional encoder repository from transformer. It was made. The paper was published by developers from Google. It gives state-of-the-art result in NLP, even with also with the classification task. The thing about a BERT is that it has bidirectionality. That means that it does not look into the relations of a sentence just from the left side, but also from the right side. So it looks into the sentence from both sides, which make it possible in order to, if we speak in the layman voice, that it says that if I'm looking into a sentence like my name is Bibek Upadhayay, I'm not starting from my name is Bibek Upadhayay. I'm also looking at Upadhayay Bibek is my. It's in that order also it looks into the sentence. That makes it possible in order to establish the very good relationship between each entity within the sentence. The classification task is done in BERT simply by adding the CLS token. But the problem with the BERT is that it has been trained in a very big data size. So that's why it has a very large parameters, somewhere around 110 M. Even the BERT, that is, I'm talking about BERT base. If you look into BERT large, it has 340 M parameters. So it's really huge. And it's when we're thinking about deploying our model in a real life application, it becomes really difficult. So that's where the concept of distilled bursts come in 2019. Victor San and his team gives the distilled BERT model. So what this is the idea is simple in a distilled BERT that is based on the knowledge distillation, which means that they're going to compress those technique in a small model, but that is going to produce the same kind of behavior as a large model. And that is possible by teacher student model. So train a small student model that mimics the behavior of the teacher model. So that's what make it possible for the digital bot, and we're going to use a digital bot in our experiment here. Let's talk about data set, because in order to perform classification, we obviously need the data set. And there are these data sets that have been very good around since few past years. As you can see that we need to look into three main things. So what are the input? What is the data size? How many data we have, and what are the levels, right? So a liar is one of the most popular. It is a short claim by the speaker. It could be House of Representatives or anyone. Data size is nearly equal to 12,000, and it got six level. So that means pants fire. Either the news could be pants fire, false, barely true, half true, mostly true, or true itself. This is short claim, and fever is also short claim. It has a greatest data size. It got 3 grades. Similarly, we have BuzzFeed News, BuzzFeed that are extracted from the FB post along with the FB post link. The thing about this is if you go and try to look into that post, if you click on that post, the post doesn't the post doesn't appear because most of them has been deleted. So when we try to access those articles, what's behind that, it will be really kind of difficult for in this period of time. Similarly, there is some like it hoax, a theme, Credit Bank, Fake News Net, BS Detector, and the other one is Kaggle Fake News. If you look into the data size, it is not that big. It's only 20,800, and the input is article, and it has a binary classification. It has either the news is fake or true. Let's talk about live data set. If you look into the distribution of label, as I've told that it has 6 label. It is a short claim, and it is derived from the politifact.com. And the data set consists 6 label. The training data set is 10,269, and the validation is 1,283. And we have used this live data set in most of our experiment. Kaggle Fake News, it is provided by Kaggle.com. It has 4 columns: ID, title, author, text, and label. And the dataset is around 20,000. And as you can see, the distribution, it is like a very nice distribution between the true news and fake news. Now let's talk about the machine learning approach, what has been done in the past. So for the live data set, they use LSTM with no attention mechanism. And we can see that the accuracy is not that well. It's only around 40%. And when they use the live data set with the same, including text plus meta as an input and using the attention mechanism, we can see that accuracy is somewhere around 41%. So there are 2 things that we need to notice, that not only the text, but also introducing the meta features of that data. And by introducing attention, we know that we can increase the accuracy. So this one thing that we kept in mind while performing our experiment. As we can see that LAT has also been used, the LSTM with attention that has accuracy of nearly 41%. And by using the same live data set with the SP2C, plus with the same base model, even we can see that the accuracy has been increased to 45%. So if we look into the input of the data set, and if we try to increase the meaningful parameters or meaningful attributes in the input center, we can see that accuracy increases, and accuracy has also been increasing with the attention mechanism. So the other one is live data set is CNN model 0.274. I've seen that I think the same experiment has been performed with the attention mechanism, in which also the accuracy has been increased. Okay, so these were the models that we studied before. Now let's talk about what we are proposing as a model. So here we are looking into a classification of fake news by 3 perspectives. The first perspective is a knowledge-based classification, in which we will try to classify the news article based on its authenticity And we're going to do that by extracting knowledge from that article and try to fact check with the existing knowledge source. So that's one perspective. The second perspective of is based on the style-based classification, in which we're going to classify our news article based on its intention, whether it is trying to mislead or not. And we do that by analyzing the pattern on that fake news as the definition of the fake news, that they try to intentionally try to write those fake news. And whenever that intention is included in a fake news, there is always a pattern that are mostly provocative pattern. And we'll try to analyze that pattern from the attribute based and structure based of the language features. And the third perspective that we're going to work on is the propagation and credibility based classification, in which we're going to classify that news article based on how it is being propagated, who are the user trying to engaging in that news. I'll be explaining the perspective 1 and perspective 2 later on, but right now we're going to focus on style-based classification. So style-based classification, this is where we're trying to have the deception detection using the deep learning models. So as you know that fake news are written in a kind of style of exaggerated expression, and it's always with a strong emotion. They have this aim, there has this intention behind that fake news that try to mislead the reader. So deep neural networks are really good at deception detection. That's why we're going to use a deep neural network for this one. And while we're using the deep learning, it is very good at automatic feature extraction rather than using non-neural network methods. It will extract both the simple feature and also the complex feature. That means synthetic and both semantic features. And we used two models, BERT as a classifier and DistilBERT as a classifier in our model. And the dataset that we used is a live dataset, a Kaggle fake news dataset, and we modified our live dataset with much more input in order to achieve more accuracy. So let's talk about the modified live dataset. At first, what we did was we tried to convert the binary. We tried to convert the 6 level into the binary level by assigning 3 of them into true and other 3, for example, false value true and finds 5 to the false level. The second modified live dataset, what we did is we introduced the sentiment in that live dataset, and we also changed the speaker name to a speaker ID, because most of these were short claims. So for example, if Barack Obama is saying something, and if there's another name up there, is someone's claiming Barack Obama, then that might kind of bias the model. So that's why we introduced the speaker ID, which is the speaker name into speaker ID. And in order to introduce sentiment into that data set, we added sentiment for positive and negative. For this, we used Google's NLP sentiment analysis API, and we added that sentiment in the dataset 2. So dataset 1, we have dataset 2, and we have dataset 3. So this is a live dataset, and this is an adaptation to dataset 2 in which we introduced emotion. As you can see that the speaker is changed to speaker ID, and we added the Google sentiment over here. I think it's missed over here, sorry for that. And also we added the emotion, as we can see that emotions, and for the adding emotion, we use IBM NLP API. So here's the emotion for this particular statement: anger, disgust, fear, joy, and sadness. So these are the 5 emotions that we introduced in our data set. Now let's talk about the model, that how we used BERT and DistilBERT in order for our experiment. So first, let's talk about simply the DistilBERT. So in DistilBERT transformer, we are using some 68 feature and trying to add a linear model at the top of the DistilBERT with 0.3 dropout. It is a lightweight BERT, and we're using BERT based on case tokenizer and with the loss function of BC with logist loss. The second one is our own approach, that is DistilBERT with a neural network on top. Here also we're using the same tokenizer, BERT based uncased, and we add a vanilla neural network on top of DistilBERT. And what we're doing over here is that we're using the DistilBERT model and trying to feed the tensor of 1 by 1 in addition to the emotion tensor of 5 by 1 into a neural network. So why we're doing this? Because when we're sending these emotions, as you look into the data set, these emotions are in the decimal values, and we're trying to send the decimal values inside a distilled bird. It will treat it as a string, and then use the word embeddings in order to do that. But we try to look what will happen if we uh, try to mix the output of the bird and the emotion into one tensor. We are concatenate those tensor and train another neural net in order to find in order to classify. So this is basically, this distilled bird is training based on the target over here. Then it will give us the result of 768 by 1 vector. Then we're going to add this. Then after that, it will give us a 1 by 1 tensor in which we're going to add this emotion. And we're feeding that 6 by 1 featured in a linear model, and we're training that. Now let's see what was our experiment output. So first we started with multi-level classification using the liar data set. This is the normal liar data set. We haven't modified anything over here. We're using it for a multi-class classification. And we can see that the accuracy was not that good. Even we increase the epoch, the accuracy is not that good. It's because when you look into the distribution of the data set, there are not that much value for the model to be trained properly. So that was one of the reason. Now, when we modify the liar data, now let's talk about first binary level Kaggle fake news data set. In here, we have the input of the text and label, and we can see that the model did not perform well in this one also. But when we modify the liar data set with by converting it into your binary labels, true or false, the accuracy has been increased to 57%. So these three models over here, we're trying with the dataset liar dataset 1, modified dataset 1, liar modified dataset 2, liar modified dataset 3. And as you can see here, we are changing the input respectively. So this is a modified with the binary output. This is modified with the binary output, including the sentiment. And this is a modified binary output, including sentiment and emotion. So we can see that the accuracy has been increasing slowly. Even the F1 score, as you can see that F1 score are increasing, which tells us that by introducing more meaningful features into the input of the model, we can increase our accuracy. So this is the third model that is based on the Vanilla neural network on top of distilled bird. The model did not perform well. Even the accuracy is good. We can see the F1 score that tells us the model is not that accurate. Now let's look into each. So this is basically distilled bird with the binary Kaggle. Accuracy is not good. So we mostly focused on the liar data set. This is the previous model, the Vanilla neural network on top of neural distilled bird. The thing over here is why the model did not perform well is because of the entropy loss. Because when we try to back propagate from the target over here all the way over to here, it does not happen like that, because we're training this model separately. First, we're training the distilled bird based on this target, and we're gathering all those output here. Then we're concatenate that output with these features, and these two features are feeding separately into the linear model, and we're trying to train that independently, right? So when we're treating both those models independently, it suffers from the entropy loss. So that's why even the accuracy is 56%, the F1 score is only somewhere around 0.360. The other result is, this is basically what I explained before. This is a liar data set with a liar data set 3. So we can see that the accuracy is increasing by changing the value, by changing the meaningful input. So by adding sentiment, we receive the accuracy up to 62%, and by this is increased by 5.63%. And just by increasing emotions into the same data set, we can see that it is a 0.6645% accuracy that means the accuracy has been almost increased by 10% from W3 physics experiment. So now we can see that this experiment is performing better than the previous experiment. So now all those three models, our own models, have the accuracy of 57%, 62%, and 66%. And we can see that the past work, there has been accuracy up to 45% maximum. And that also when they are introducing the text plus meta plus space to see. So they are also introducing attention over here, and we're using the Distilbert, which is based on attention mechanism. So we can see that by introducing attention mechanism, and if we introduce some meaningful parameters into our input, then the model will always perform well. So what's our future work? Over here, we can see that when we're adding vanilla neural network on top of Distilbert, our model did not perform well, right? Because when we're trying to backpropagate from here to here, we're treating both a single model, we're training it independently. So that's why we're proposing another model in future work. That will have the CNN model within the Distilbert itself. So what we're doing over here is when the BERT transformer will, after the dropout, the output of the Distilbert, we're introducing the emotion feature right over here, and then we're using the CNN model, or we'll be using the CNN model with the 768 plus 5 features to 1. So this whole itself will act as a BERT model. So this will allow us to backpropagate properly and turn this two model into a single one. So this is one thing that we have in mind that we're going to work in our future. What we're going to do over here is the other thing that we're going to work on is multi-class classification. Since right now we're mostly focused on the binary classification, but now we'll be focusing on a multi-class classification by introducing sentiment and emotion by adapting those. We're using Distilbert so far, but we're also going to use OpenAI GPT-2 and OpenAI GPT-3 with all those modified live data set. The other thing that in our list is to work on to create a fake news data set, much more, not only the short claims, but the actual news article by scraping the news website. So this is in the list of our future work. Now, let's talk about two perspectives that we are proposing in our model. The perspective 1, knowledge-based classification, and perspective 3, propagation and credibility-based classification. So we will work on, in order to introduce machine learning model that will identify the false news by extracting knowledge from the source, and that will compare it to the viable sources. So this is the one thing that we have in mind, and we're still working on to propose a model that will work on this. The other thing that we'll work on is a model that will classify the fake news based on its propagation dynamics, like how much the news is being shared, and the users that are interacting with this. So this happens because of if you look into the propagation pattern, then fake news propagate like epidemics. As we can see that just coronavirus is caused by 5G. Even in the YouTube, it has like more than 10 millions of views, right? So we can look into the propagation of a fake news, the propagation of epidemics. So in order, on the basis of that, we're going to analyze whether the news is either fake news or not. We can also use look into the temporal pattern analysis that fake news spreads different than the true news, obviously. The reason behind this is, for example, someone writes status or tweet in a Twitter that, or for example, it is from an unverifiable source that writes some fake news, then not only there are comments from that community, but also from viable users that are complaining about the news that it is fake. Or so that makes the machine learning algorithm to boost that news and spread it much faster than the true news, because kind of Facebook algorithms will work like that. The more interaction it has, more it will appear in the news feed. So that's how it happens. And we're also going to look into user interaction analysis, which users are interacting with the content, because as I've talked about the echo chamber effect, people have that sorts of filter bubble, and that communities in which that communities tends to interact more with those kind of news. So we're trying to separate our user into credibles and non-credible categories based on which they will interact with, based on which their interactions, we're going to capture that and classify the news articles based on that. Now let's see the demo. So here's the demo of our.
Bibek, you may need to change your share the screen. We don't see the demo.
Yes, Professor. Just thank you. Okay. Can you see it?
Yes.
Okay, great. So this is based on the latest experiments that has the accuracy of 66%. So first, let me connect to the runtime. Okay, we have GPU. Let's. It will just take a few minutes, like 2 minutes maximum. I have already trained the model. I'm going to use the SEB model, so it won't take much. Okay, we're almost done. Okay, so let's load the model. Now we're loading the model. Okay, sounds good. Okay, I think I just. Okay. Okay, well, first let me show you what we have achieved over here. So we have here we're using the live data set, but with the validation data set. So in live data set, they provided us with the 3 data set. One is for the training, one is for the testing purpose, and one is for the validation purpose. So the model has never seen the validation data. So we're going to use that. The reason behind this is we're going to use the actual, because most of the live data set is back from 2016 and 2017. So those news, we're using the same news article from 2016 and 2017 and the same sort of claims. So as we can see that the label 0 and 1 suggests that if at the left side, if it is 0, then the 0 here denotes, 1 here will denote the true, and 1 here will denote the false. So basically this is a false article. The subject of the article is animals federal budget. The content of the article is President Barack Obama is the first president to keep a drug trainer on retainer for $102,000 a year taxpayer expense. This is basically the sources chain email, and this is basically the emotion that we have introduced in the input text. Similarly, we can look into the true news. For example, let's look into this one. The subject of this is child health care, public health taxes. Here is the short claim all the way over here. And we can see that it is said by Mr. Dennis, who is a US representative. He's a Democrat, and it was a news release. And here we have the emotions over here. When we try to run these 10 categories news, when try to run that through our model, we can see that here's our prediction and here is our target basically. So this is our news. So this is, we can see that this is a false news, and our target is 0.0. We can see that probability scores is 0.47, something around that. So it's basically less than the 50%. Here, this is also fake news about gays and lesbian marriage. And we can see that the target is 0.0 and the prediction 0.37. So if we change this prediction into true and false, this is our actual output. So we can see that if a news is false, this was a false news, this was false news, the prediction is false news. But most of the time that I was trying to work on this one, it was, if I'm giving 12 input, it was giving me 9/12 output. So it always don't predict, because the accuracy is somewhere around only 65%. So I think this is performing good on the data set, validation data set that we have. Let's look into where it went wrong. Here, the prediction, here, this one, you can see that the prediction is true, but the target was false. This is third last. And over here, we can see that third last over here, it was for the marijuana topic. Here, marijuana topic, you can see that it went like, it is really hard. That's 70%. The prediction score was 70%. So let's look into the input. Yeah. So it was said by Dan Feinstein, a US Senator Democrat, Northrop campaign press release, and here's the emotion. So even the thing is, if the model does not know, right now it is looking into the lexical based features. It is looking at semantic and syntactic features, and it is not performing at much more higher accuracy because it don't know that, it don't have that knowledge based capabilities. So that's why we cannot only rely on the deception detection for the fake news classification, but we also need to look into the other two perspective, that is knowledge-based classification, as well as the propagation and credit-based user-based analysis for the fake news classification. So that's why we're proposing three perspectives rather than only the deception detection. Let me see if, I think I mistakenly saved the previous model, so not sure if this will do the same thing. In order for this to work, I need to retrain it again. So okay, let's see if it worked or not. Okay, so every time I do the label, for example, if I go over here, the news will change every time it's taking the random news article. So we can change this to something else. Here we can see that news article has been changed. Let's see if it will perform. Okay, so it did perform well, 7/12. Okay, so we can see that with the different text, we have new level, new text, and new level for them. You can see that this is our target and 111, and it is performing well in some. And here, let's directly look into the true or false. So true, true, true is performing well in this one. Here also it gives us the true, true, true. Okay, so basically the prediction, everything is true. So I apologize for this one, because over here I just saved, I override the same model. So that was the one problem. But I don't think we have that much time in order for me to retrain the whole model. So let's focus on the previous output that we have again. So that's for now. Let me go back to the presented slide again. So that was the demo. Thank you so much. If there's any question, I'm happy to answer them. Thank you.
Bibek, thank you so much for this excellent presentation. I have, as usual, a number of questions to ask. But before I get to my questions, I want to open the floor to the audience. If they have any questions, any thoughts, any comments. Sai?
Hello, good job. And I like all of your lovely Transformers and Bert from Sesame Street.
Thank you.
um, Now, I apologize if you did mention this. My speakers aren't great right now, but how do you go about, or do you have any plans on figuring out how to go about identifying that the model is showing that the news itself is fake, but not necessarily all of the content? For example, let's say someone says that pears are blue. We want to identify that that's fake news, but not necessarily in the future see that something about pears pops up and that's labeled fake news. If that makes sense.
Oh, that's a very interesting question, Sai. Just for the sake of
Yeah.
historical perspective, I'm going to rephrase your question.
Please do.
Yes.
Bibek, how do you know that your model is not biased towards certain keywords or certain categories? For example, I noticed that your model in the demo kept incorrectly classifying fake news attributed to Democrats as a genuine piece of information. Do you think that's because of a data set bias or a model bias?
For this one, I'll say it's a data set bias because most of these are from, if you look into the data set of Liar, so most of those contents are from 2016 and 2017 by PolitiFact, and there were lots of things going on from both sides. There were most of the claims, so they were mostly trying to capture those false claims, and they were trying to sample it from every speaker. They're not trying to get the claims, for example, from a Republican president running candidate only, but they try to get those samples from all the other candidates as well, right? So if you look into that, so for example, Mr. President Trump, is one of the candidates leading in Republican, right? So there might be many more in the Democrats, for example, many more in the Democrats that are saying false things about that. That and what PolitiFact does is PolitiFact collects those articles, those claims, and those articles, and keep them in the data set, right? Now, that's good for them. They are doing their job. But if you look into the machine learning model, we can see that, okay, most of the negative claims in the 2016, 2017 is being said by Democrats. So this is more of a problem into a data set. So this is why I mentioned that in our future work, we need to work on our data set because we cannot rely on the other people's data set. So that's one thing we need to know. The other thing, I think Sai was mentioning about label. Sai, I just forgot the question. Can you please repeat that?
Sai, I think you're on mute.
I am sorry. Could you just repeat what you said? The last part. My mic.
Okay. So as Dr. Baid gave, as Dr. Baid asked me, so I'm saying that it is more of a more dependent on the light. It is more of a data set biased thing because it depends upon the data set that we are collecting. Because we are training our model on based on the data set, right? So we need to make sure that our data set is fair. We're not only collecting right now. If you look into the live data set, it is mostly collecting short claims, but not actual news articles from all those fake websites and fake posts. So in the future, this is one of the work that we're going to collect the fake news by ourselves by scraping the web for the content and make sure that the data set is not biased towards a particular party.
How are you going to combat biases of the analysts themselves?
That's a great question. So that's what we need to work on, because I think in machine learning, like having a good data set is like 60% of the work. Mm-hmm. So that's our 60% of our work. So we're going to make sure that we are going to, when we are scraping the content, we're going to make sure that we're not only scraping from left-wing media, mainstream medias or right-wing mainstream medias, but we're going to focus on much more into while scraping. We'll look into the websites that don't have any biases towards any parties. That's the one thing that we have in mind.
To supplement Bibek's excellent answer, I want to mention that the answer to your question is the root and motivation for a growing and major community in the research community in the machine learning domain. It's called the Fairness in Machine Learning Research domain. It popped up a few years ago after noticing that a lot of the deployed machine learning models in areas such as the justice system or mortgage decision making are biased unintentionally, apparently, against certain protected minorities or certain attributes that should not have been a factor in the decision-making process. Of course, some of the bias comes from data. This was a topic of discussion in the ML research Twitter community just a couple of weeks ago, just a week ago. It's not the bias in data set and labeling is not the only root of bias in modeling. There are other roots, for example, choices of regularization during training or in the model architecture can affect the emphasis put on data bias. Mm-hmm. However, this is not a straightforward question to answer. It's not easy to answer that question. It's a topic of discussion, and it's definitely one of the things that our lab is interested in exploring. There are simple solutions related to debiasing as well as regularization and let's say other techniques that have been used classically in sampling and statistical modeling, but they're clearly not enough. There needs to be more done. I can share more resources on current efforts and state of the art in fairness in machine learning on our Slack channel. Hopefully we can follow up on this discussion in more depth and detail in the near future.
Absolutely.
Thank you, Sai. Do we have any other questions from the audience? Sam?
Professor?
Milan, Sam had his hand up. Shall we go with Sam first?
Yeah, sure.
Yeah, so I have two questions. So I saw that in the data set you added motions to it.
Yes.
Did you notice any, like, with, you know, the fake news, were there any specific emotions that you noticed that, you know, correlated to more fake news or anything like that?
I think, like, I haven't actually looked at the distribution level of the emotions only, but in terms of the sentiment, there are mostly negative sentiment. So that means, like, most of them were in the I think in the emotion when I was looking into the few of them. So basically this model, it is being trained on the decimal value, right? But last week we also trained a model in which we are converting, like, for example, fitting the maximum values. For example, if we have the maximum value here is 1.98 to joy, right? So if you look into over here, it has a value of 0.36. So we were fitting joy into the model instead of all those values. So it did not perform that well. But to answer a question, when I was working on that, most of them have anger and also disgust. So these two that I cast with my eyes, but I haven't looked into the distribution of the emotionally. But surely I'll do this. I'm obviously working on in this experiment, I think this week. So I'll be happy to share that with you.
Awesome, thanks. And my other question is too, was there any, like, correlation with, like, buzzwords or, like, specific, you know, wording of phrases that helped you, like, determine any fake news or anything like that?
Right now we're looking not only, so what we're doing right now is we're fitting all those into a tokenized, right? So we're not trying to fit a separate separate keywords. I think no, I haven't noticed such kind of correlation between particular keywords only, because right now we're just feeding all those information at once, and so I think if we have that, we need to find out, because that keywords might bias the model for that particular thing. Here, we had the same breaks with the speaker. For example, we have Rick Ferry over here. There might be Rick Ferry missing somewhere in other person's statement. So that why we change this to ID. So yep, we have right now we haven't observed something like that, but we surely need to focus on that to see if it is being biased into something.
All right, awesome. Thank you.
Thank you.
Thank you for these excellent questions, Sam. Milan, would you like to go next? Milan? I think he may have been disconnected. Vikram, would you like to go next?
Yeah. First of all, just confirm that you can hear me and that there's no echo.
It's perfect.
Okay, great. I'm playing off my speakers. So yeah. So this was really interesting. I'm just curious. So you're a master's student at UNH, and how long did it take you to kind of put this together? From like initial idea of this is kind of what you're going to study, and then to this first kind of experiment that you've done.
Okay, so basically me and Dr. Bad, we've been working around 6 months for this whole thing. Yes, I'm a master student at UNS. I'm a CS grad student. Yeah, we've been working on this since 6 months. So first, basically, we started with the literature review, and then I think after first 2 months, we started with the experiments. We basically started with the very simple. I think I worked on naive-based classifier using I think that was a cattle fake news data set. Just to know the basic, like what happens when we're classifying the news article. We're trying to look into that. After that, we certainly move into a CNN. CNN did not perform that well. Also, we did not use attention mechanism with the CNN, so it did not perform that well. So after that, I have experience with BERT before, so I thought let's start with the BERT. So we there were a few experiments that we worked on the BERT also. I'm not sure if I.
Okay, so this is about the third experiment that you've done, kind of third in series that you've done.
Yep.
Yeah, sorry, I just need some contexts because I don't have any. So
just let me show you the. Okay, I think. So actually, these are not like 1, 2, 3, 4, 5. These 6 were not the only experiment that we did. This is the one with the accuracy a little bit higher than what we have performed, and these are for the presentation. Those that are relevant to the presentation, like to make sense on what's going on. This 6 experiment is for our progress, like how we learned to increase the accuracy up to 66%. But beside that, also we have worked on many models which did not perform well. One typical example is this one. Like we just added a neural network on the top of the digital board, right? So there was one that we have worked with LSTM also. It did not perform well. So it depends a lot on the data set, and it also depends a lot on the model that we're going to use. Yeah. So we observed that when you're trying to introduce a live data set in the BERT model, it was performing really well. So we said, okay, let's try to modify this one. Let's try to increase the parameters by introducing sentiment as well as the emotion. Then we keep on seeing the gradual increase in the accuracy. So that makes our model good.
Yep.
That was our approach.
So what was the decision behind let's use this emotional API, and also basically is the IBM NLP model, I mean, does that have a semantic model behind the NLP learning process, or kind of labeling process?
Sorry, what was the last question?
So do you know, so first I wanted to know why you decided to go with the emotion API. Yes. Second, I was kind of asking just a little bit about how that API does what it does to label. In other words, is there some kind of knowledge representation semantic model behind that? Or does it simply go and look for words associated or synonyms with words that correlate with anger?
Okay. Here, I'll start with the first question, why we introduce emotion into the text. Okay. The thing is, by the definition of the fake news, if you look into that, there is always intention, right? So either those were provocative, they're misleading. If you look into the fake news, they are mostly written in capital letter. They have a whole complete sentence. If you look into true news, it has like 6 to 7 words in their headlines. If you look into fake news, they have like a whole complete sentence in the headline, and those have a kind of like a negative sentiment to it. They are trying to provocate. They have more emotion that tends towards anger or something like that. So fake news, they always have this intention, and those intentions we want to analyze that via the emotion. So that's why emotion comes into play. Most of those fake news that we have like bad intention with the negative sentiment. So we thought if we introduce emotion, then models might learn based on that. Like when we introduced sentiment with the Google NLP API, we saw that most of the fake news, most of them had the negative sentiment.
Yeah.
Like it was really hard for us to find the okay, this news has positive sentiment. So most of them were negative sentiment.
That's something that you discovered, but in terms of previous work that might have shown that this is a clear representation. And I would assume that what you said makes sense, because the whole reason they're doing disinformation is to evoke emotion, evoke a very strong response.
Yes. Okay. But I did not find the same thing in the previous work that has been done in the previous work. So this was what me and Dr. Badu discussed about, and we implemented it, and we saw the accuracy was being increased.
Vic, sentiment analysis has not been used in this particular domain as far as we know. However, in other related or similar work, you see that sentiment analysis and sentiment and emotion values can bring some interesting information into play. Examples include using social media data to detect or predict the increase or decrease of value in certain stock. Right. For example, if you look at Twitter data and check the sentiment of tweets about Apple, if you track the evolution of that sentiment, you may be able to use it in predicting how the Apple stock is going to change in value in the coming days or hours. With regards to your second question of how the IBM natural language processing API or the Google API do perform the sentiment analysis and emotion analysis, both are based on similar machine learning models. Mm-hmm. So there are data sets of pieces of text manually tagged with the emotion that they represent. And then there are deep learning models trained on those data sets to perform this sort of classification. So sentiment and emotion analysis is another instance of a classification problem.
Right. Yeah, and I would assume that the way that that's first done is again something similar to what I said, where the data set is labeled with synonyms or words that have a certain connotation to them, and that's how it's classified. And so I agree with Sai's comment. I think the two most important things, and I mean you know this, you stated this yourself, Bibek, but is going to be how it is labeled, how the data is labeled, as well as how the model, how you put the model together. So so this is all great, and I'm actually really interested in this topic. I think you've done a lot of good work in 6 months. This is pretty impressive. I'm curious, as a last question here, have you seen your correlation numbers, or what you basically say is F1 or accuracy, they're around like 60% maximum. Have you seen other other work where that number is much higher, or are they all kind of in this ballpark area of some confidence, but not a clear enough one to say, okay, well, we can just fully trust the model to do it for us?
Yeah, I believe, I think this was like 2 days ago, me and Dr. Vaid were looking into a model that has like the same live data set. I think they had the accuracy of somewhere around 92%. They use deep CNN and they only faded the text. So we look into the paper and uh, we we kind of sense that it's not that much of an accurate model.
Right.
So there were a lot of things that were missing in details. So we said, okay, this. And we came to know about this model by reading the survey paper. So we thought, okay, that the person behind the survey that did not actually look into detail into this model. So that's why when we're looking to the past work, we're looking into what they have done, which model they are using, how they are achieving that, and the good models that we found that did not perform that well. So that they were somewhere around like 40%, 45% only that. And the model that performed that really, really well, for example, like 92%, 96%, when we look inside their paper, we can see that there are lots of information that were missing in that model. I think, that's why you try to stick with the model that has the average accuracy, that has everything explanation and what they are doing, how they are doing it. So that's why we kept the that previous works only in our presentation also.
I'm going to follow up on Vic's question. Bibek, can you go back to the slide where you have the table of results obtained in previous works?
Yes, Professor.
So I think you passed it.
Oh, sorry.
There it is.
Okay, I think this is ours.
This is ours, right?
Okay, here you go.
Right. So looking at these results, what we see is almost all of the accuracies are below 50%. It means that all of these models are performing worse than coin toss. I'm curious to learn how these papers justify their efforts and whether you've come across any comparison between human performance and machine learning performance in detecting fake news.
Okay, so I haven't come across the comparison between human detection and machine learning detection. I haven't come across that throughout the 6 months. Sorry, what was the first question, Professor?
How do these papers justify such horrible results? How do they justify putting so much effort into creating something that performs basically worse than coin toss?
So I exactly cannot say how they justify, but based on what I've seen in their paper, most of them also, just like, for example, if you look into Wang paper 2017, he not only worked on the CNN, but I think he has worked with the other model as well. So and other data set as well. So I think these papers are also working with more than 2 data set and 2 models. So when they are justifying their poor results, they have a little bit of emphasis on the data set, about how the data set is not enough for their model to be trained. So that's I think I found that in 2 to 3 models. So they try to emphasis on the data set.
I think one of the things that we can do to advance the state of the art is to first do a study and see how well layman users or typical human consumers of these information perform in detecting fake or true news based on the liar data set or similar pieces of data. And that may give us some baseline to beat. So in vision processing, the baseline was for many years how well expert human annotators do in annotating different images. And the success of deep learning was revealed when that baseline was surpassed using CNNs. This is one of the things that we should definitely look into at some point.
Yes.
Also, again, it's noteworthy to see that machine learning has not been doing so well. We came across one or two papers that reported extremely high accuracy levels for their models. And it was kind of obvious that those results were inaccurately reported. Their models had overfitted on data, and we could not trust those levels of data. But our aim is to get there, right? Our aim is to not only perform better than human decision makers and human users, but also to bring our accuracy levels to as close as 100% as possible.
I have a quick couple things to say about that.
Sure, Vic. Before we move forward, I think Milan has had his hand up for some time. Milan, would you like to wait until this discussion is over and ask your question, or would you like to go ahead now?
I like to.
I'm sorry, I didn't catch that.
Yeah, I would like to wait, and
Okay.
I'll add the discussion. So.
All right, thank you, Milan. Vic, would you like to go ahead?
Yeah, so this was just a quick comment. So the reason I was brought into this was because I'm really interested in deception. I have some prior cyber deception experience, but obviously deception is a kind of a buzzword, a big bucket category, which you can identify a lot of these smaller problems by. And so obviously, since I'm thinking about trying to, this is not the only thing, I'm actually moving away from this potential topic now, just because non-US schools for PhD, they really want you to have some previous experience and kind of have a really scoped idea. And I'm not a machine learning guy per se, even though I understand some of these things and concepts. So I was talking to my dad about this, and he said, and I looked this up, I did a little bit of Googling. Just about 2 or 3 weeks ago, Microsoft announced that they're laying off some of their journalists. Each of their articles are written by 3 journalists usually. And now the AI or ML is so good that it can write the paragraph forms for you. And this is clearly what you've been working with. Basically the, one journalist is being laid off, so the machine can overtake that, and the 2 other journalists will correct it. And then another thing I found through kind of then doing a little bit of what can I find on that topic was, I think just last fall, there was an article about a trained, very experienced FBI psychological analyst who's usually, able to understand when people are lying through lie detectors, interviews, things like that, interrogation. They asked him to read a bunch of paragraphs and determine if it was a human or a machine, and he could not tell. And it actually, when you look at the article, every single paragraph is written by a machine, and it sounds perfect. So I think that that's definitely a step you need to do is not only for your baseline, but then you also have to consider the future of this, right? So let's say that humans can no longer determine what is reliable. Well, now should we trust a machine to basically tell us completely this is actually trustworthy? I mean, it's the flip side of not disinformation or fake news, but even just trusting real news, basically. Can I trust this, or do I just wait for the machine to check it and say that? I guess there's both sides of the coins. But so the whole reason I asked about the NLP thing was I'm involved with a project that Sam actually was an intern for me.
Right. Vic, before you continue, I just need a quick reminder before you share information about that project. This recording will be uploaded on YouTube for public consumption. Just be aware of that.
No worries. It's a public project, and I'm not going to go into detail. But the point is that it is an ontology, and that means it's more than a data model, meaning it's not just a pure binary tree type of thing, right? Where it's very, at the very top, you see one node that everything derives from, right? There's there's higher complexity to it. And so the reason I asked how the NLP, IBM NLP was done was because one aspect of identifying these more complex structures is to put semantics behind it. So Sai brought up that you have the data model itself has to be validated as this is how I'm defining fake versus not, and this is why. And what makes that easier is not simply just saying, oh, well, this word has this connotation, but describing the relationships between the words, right? So then you start to have a semantic model or a more ontological model. So one thing that people are trying to do now is called automated reasoning, which is they're using that more complex model. You can think of it like a tree, but it's much more complex. And then and then using machine learning on it, right? And so there's some level of the semantic relationship between things that are already built in. So I just wanted to mention that that might also be something to look into, because if you are it might improve your accuracy there to the point that because that semantics is built in, it's more human level understanding, right? So I would say that's another thing that you need that you could consider is there some level of modeling I need to do behind whatever process you're applying, which in this case is the IBM NLP. And I'm sure there's other APIs or technologies you could find that do that.
So Vic, thank you for bringing all of these up. These are all very good points. I'm going to start from the last point that you brought up. Semantic modeling has traditionally been the bane of NLP researchers' existence. And of course, their reason to wake up in the morning as well. One of the interesting advances in the past 10 years or so has been the application of deep learning in automating the training of these semantic models. It's possible to come up with semantic understanding of text by looking at large corpora without any human input on what the semantic meanings or semantic relationships are. And deep learning models have shown to be very well suited to address this problem of automatic semantic modeling and automatic semantic relationship extraction. We are actually working on similar problems in another project, the cyber threat intelligence project. And we are looking at both automatic ontology extraction and semantic role labeling, as well as some reasoning about the events without any human input. It's going to be difficult. Of course, human input comes from the human mind, which itself is a system that's been trained on a lot of data. If we could copy the data or the effect of data on our brains, we wouldn't need to train any models. We would just use the same brain structure to solve the problems for us. The other side of the coin, since we're talking about coins and other sides here, is human labeling and human knowledge is very difficult to codify, not just technically, but also economically. Annotation itself is a very time-consuming and expensive process when it comes to large text corpora. And we want to take that bottleneck out of the process. That's one of the things we are working on. Of course, it's not going to be 100% accurate. It's going to be dependent on previously annotated data to some point. We are going to try to minimize dependence on human involvement. Of course, at some point, we will need to come back and decide to increase the role of human in the loop to make sure that things like unintentional or intentional machine deception do not become prevalent. Now, this brings us back to your first point. Using models like GPT-2 and GPT-3 to generate text has been a topic of discussion in the AI safety community since last year, since OpenAI released GPT-2, which was able to generate very realistic and coherent pieces of text. And the very first thing that was brought up was its potential for misuse, just how easy it is to use such a model to create fake news or create fake impersonations of genuine human speakers or human writers. Since the discussion started since last year, there has been several attempts on creating machine learning models to combat these machine learning models, fighting fire with fire. There are research work and machine learning models out there that enable the detection of text generated by these machine learning models, and therefore can help in detecting the genuineness of those texts. Of course, that doesn't mean that a piece of news written by a model is necessarily fake news, but having that information, knowing that this piece of text, a particular piece of text was written by a model, was composed by a model, can be used as a feature in detecting whether something is fake or not. Now, to generalize from this, we can jump one step higher in the level of abstraction and look at it with the same lens that you guys use in cybersecurity. This is soon going to become a cat and mouse game. So there will always be models used for malicious purposes, and then we'll have to train models to combat those. And there will be a proliferation. At some point, one side is going to win, and that's a matter of time. We hope that it will be the human side, and that's part of the mission statement of this lab. In general, trusting models completely is probably not a reasonable idea at this point in time, but you need to keep in mind that we are dealing with large volumes of information, and our human brain is not capable of spending sufficient time to analyze such large volumes. So we are augmenting our capabilities by adding this machinery, these algorithms into our domain. Milan, you've been waiting for about half hour now. I'm sorry for that. Would you like to go ahead?
Yes,
Milan?
Professor.
Yep.
Yes. Yeah. So my question is that it's about fake news detection, but let's say all the data set we have, all the things we have, but still it's not very clear what's fake, because sometimes the perspective of a writer also plays a role. So let's say some editor or some writers write its own new unique perspective. So how can this model deal with this perspective thing?
Yes,
That's a very good question. Bibek, would you like to go ahead?
yes. So this is why we talk about, like, we're looking into the three perspective, but not only in the deception detection, only in the we're not going only to look at a particle news article based on its style, like how it has been written down. So that's why we introduced a knowledge-based classification also, like the news article that, even, for example, our editor from I don't want to say name, but for example, an editor from a particular news is writing something very biased towards a political candidate. That might be partially true, but it is true, but in a very negative way. Then we cannot just rely on the style-based classification. So this is why we need the knowledge-based classification, in which we can extract that knowledge from that particular news article and do the fact-checking with the other reliable sources as well. So that's one thing that we have in mind. And the other thing is that there's always to every action there is an opposite reaction. So if that particular article from that editor is in the for example in the Facebook or in Twitter, then we can see how it is being propagated, how people are taking it. So that's where the perspective 3 comes into play, like how that news is propagating, what's the how the users are reacting to that. We can tell a lot about a particular tweet or particular news article just by analyzing the comments below that. So that's one thing that we're going to take into consideration while we're building our perspective 3 model, which will be based on the propagation credit based classification. So to sum up the answer, I'll say that we're not going to look into the style based classification only, not into the how that has been written, but also we're going to look into the knowledge extraction from that article and do the fact checking, and also we're going to analyze how that news is doing in the social media based on the users and its propagation model as well.
I like to just one more thing, one more review about your review from you about the phase. It's like facts doesn't exist, interpretation does. So
that's a very good point. You're right. What we call fact is actually a high probability assigned to the outcome of a Bayesian model. Milan, I think this can lead to a longer discussion, which I think we need to have, but unfortunately we've been running longer than planned. I have to leave for another meeting shortly. Let's discuss this later on internally. Vic, you are more than welcome to join. I'm going to, Bibek, I'm going to stop recording. Once again, thank you very much for this excellent presentation.
Thank you, Professor. Thank you, everyone.